Hi, this is Nimla Rednam. In this video, we are going to continue the topic Exponents and Powers, which is the 10th chapter from NCERT textbook class 8. In the previous video, we discussed the first exercise and we solved all the sums, which was regarding laws of exponents. In this video, we are going to look at the second exercise, which deals with the standard form of exponential form, and also how do you express very small numbers or very large numbers, and when it comes to calculations with them or comparisons of very small numbers or very large numbers, how are we going to proceed? So let me first explain what we mean by standard form. So for example, here let us say I have a number. I'm going to take a very small number first, 58. Okay, so if I have a number like this, what we are going to do is I want to write it as 10 power something, and this decimal I have to move it in such a manner that this this particular number is going to lie between 1 and 10. So if I call it k, it has to lie between 1 and 10. Okay, so this decimal, if I start moving it, once it reaches here, it becomes 0.58, which is still less than 1. I want a number greater than 1. So I'm going to move it one more place, and once the decimal comes here, I have 5.8, which lies between 1 and 10, right? So this is what I require. So in order to move till here, how many places did the decimal point move? 1, 2, 3, 4, 5. So this is 5.8 into 10 power minus 5. So the concept as such is very simple, but you will kind of make mistakes if you don't understand what is this. Like for example, you have to have the clarity that how many places you're moving it to the right. That many, that will be your exponent in the negative sense, right? So this is 10 power minus 5. So in the exam, even if they ask expand this, how are you going to do it? You first write this, put a few zeros, okay, and from here the decimal is originally here, right? You have to 10 power minus negative, so the decimal goes to the left 5 times. 1, 2, 3, 4, 5. So you're going to write 0 point, and I have 4 zeros here, 5, 8. Okay, so this is simply about placing the decimal at the right point. Correct, and you have to count the number of places you're moving to the right or left. If you do that correctly, you will get your answer. Next, if I have, for example, a very large number like this, okay, then what is the standard form? Again, I have 5a, it's going to be 5.8. It can't be 58 because 58 is greater than 10. It can't be 0.58 because it's less than 1. Okay, like I said, the standard form k has to lie between 1 and 10. So once you have that, now I'm going to look at how many zeros. So I have placed the decimal over here, right? So how many zeros? In this number, the decimal is over here. So how many places do I have to move? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 power 9. Okay. So this is your standard form, be it a very large number or a very small number. This is how you're going to do it. When it comes to comparison, I'll come to it once you have that, once we come to that solved example or the question that they asked. Let me check. So these are a few examples of extremely small numbers and extremely large numbers that you come across in your other subjects, in science, in geography, in science, physics, and so on. So for example, if they say speed of light, every time you're not going to write 3 and put 8 zeros next to it and say so many meters per second. You're simply going to say 3 into 10 power 8 meters per second, right? So similarly, height of Mount Everest, be it diameter of the wire of a computer chip, all these things you're going to use the standard notation, standard form of exponential form in order to express them, right? So it's very important that you understand when someone says, for example, 1.5 into 10 power 11. you know that, if I expand it, this is the number that I get. So let's look at the try these question. Write the following in the standard form. Okay, so let's take it up in the whiteboard. The first one that they are asking is 0 point, I have 6 zeros, 1, 2, 3, 4, 5, 6, and after that 5, 6, 4. Okay, so 5, 6, 4. So like I said, first write down 5, 6, 4. Okay, 0.564 is less than 1, so it's not valid. So I have to take 5.64, correct? So in order to take it as 5.64, how many places did I move from here? 1, 2, 3, 4, 5, 6, 7. So it is minus 7. That is how you're going to answer the questions. Next one, they're saying 0. They've given 5 zeros, 2, 1. So first, what is this number? It can't be 0.21. It has to be 2.1. Correct? So in order to make it 2.1, how many places have I moved? 1, 2, 3, 4, 5, 6. 10 power minus 6. Correct? Next I have 216. I have 216 and then 5 zeros. Right? So again, what is in the standard form, I have to decide my K first. It can't be 0.216, it is 2.16. It can't be 21 because 21 is 21.6 because it's greater than 10. So once I have 2.16, so here the decimal is over here, right? So I'm going to move it 1, 2, 3, 4, 5, 6, 7. So it's nothing but 10 power 7. Next question, 1524 and then 4 zeros. So again I'm going to write 1524 first. It can't be 0.1, it's going to be 1.524. It can't be 15.24 because it's greater than 10, right? So how many decimal places? That is the question. 1, 2, 3, 4, 5, 6, 7. So again it is 10 power 7. So this is how you're going to solve questions of this manner. Write all the facts given in the standard form. Okay, so I think we are talking about these facts. They want all of these in the standard form. Let's do that here itself quickly. So this one is going to be 1.496 into 10 to the power of, from here I have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 power 11, right? And this is going to be 3 into 10 power 8, right? So you can see 3, so I have placed the decimal here. So 1, 2, 3, 4, 5, 6, 7, 8. And this one is going to be 20 millimeters. I think they want us to first convert it to meters. Is going to be 0. Or even if you're going to write it in millimeters, it's nothing but 2 into 10. Correct? So that is the standard form here. Next I have 7 into, now here the decimal, I'm taking it from here, 1, 2, 3, 4, 5, 6. So 10 power minus 6. Okay, write the units as well. This is millimeters. So 0.005 is nothing but 5 into 10 power minus 3, because if you look at it, 1, 2, 3 centimeters, 2. Now here it is 1 and 2. So 1 into 10 power minus 2, okay, centimeters. Now distance, which is giving in meters, So I have sixth question, I'm going to write here 3.84467. Okay, 3.84467. So the decimal is moving from here 1, 2, 3, 4, 5, 6, 7, 8. 10 power 8 meters. So that is the answer. Size of the plant cell, the K is 1.275, right? So if I have to place the decimal here, I'm moving 1, 2, 3, 4, 5 places. So minus 5 meters. Okay. And here it is going to be 6.95 into, from here 1, 2, 3, 4, 5, 5 kilometers. Mass of a propellant in a space shuttle solid rocket booster is so and so. So 5.036 into 10 to the power of 1, 2, 3, 4, 5, 5 kgs, right? Next, thickness of a paper is 1.6 into 10 to the power of 1, 2, 3, minus 3 centimeters. Okay, diameter of the wire 3 into 10 to the power of, so I want the decimal over here 1, 2, 3, 4, 5, 6, minus 6 meters. Okay, so next is 8.848 into 10 to the power of 1, 2, 3, 10 to the power of 3 meters. So these are the facts in standard form. Next, how do you compare very large and very small numbers? They're asking us to divide one by the other, and then you will see that if the ratio is greater than 1, then the numerator is greater than the denominator, and so on. But in order to do that, you will be having a lot of these kind of numbers which you have to have an idea of, or you can proceed in this way. Or another way that I would like to suggest, which actually will help you even if you have to perform operations like addition and subtraction on them, is you try to get a common, now deviate from the standard form and try to get a common exponential part, and then you can deal with the other part over here, right? So for example, let's take this example. I have I have 10 power 7 here, right? So if I write 1.4 into 10 power 9 in terms of 10 power 7, okay, that means I am taking away two zeros. 10 power 9 is 10 power 7 into 100, and I'm going to write it over here. If I multiply this with 100, I'm going to get 140, right? Now if I have to compare this number with 1.2756 into 10, it's going to be very easy. You can clearly see that this is greater number. You can easily calculate operations like addition and subtraction over here, right? Because this is common 10 power 7, you take it outside the bracket and add these two numbers, and if you have to subtract, you can subtract these two numbers, right? So that is one way of looking at it, of comparing two numbers. If you have extremely small numbers also, for example, I have these two small numbers, right? So what is the standard form? First, we will have to write it in the standard form. This is 1, 2, 3, 4, 5, 6, 7 into 10 power minus 6. And this one is 1, 2, 3, 4, 5. 1.275 into 10 power minus 5. Now, I want 10 power minus 5 for both of them. Okay. If I have 10 power minus 5, okay, that means I have to write this as 0.7 into 10 power minus 5, and this one is already 10 power minus 5. So you can clearly see that the RBC is smaller than the plant cell, correct? Because it's 0.7 and here it is 1.257. Okay, and now I can add and subtract, and if they have asked us, then it's easier to do it when you have it like that. So that's what they have done here. You have mass of earth, mass of moon. They've written both in terms of 10 power 22 so that you can do the addition part easily. Okay, so that is about comparing, adding and subtracting two very large numbers or two very small numbers. Express in standard form. Now this one is 3.5 into 1, 2, 3, 4, 5, 10 power minus 5, and this one is 4.05 into 1, 2, 3, 4, 5, 6, 10 power 6, right? So that is your 8th example. 9th example, express in the usual form. So you have to expand this. I have 352, put some zeros, and from here I have 1, 2, 3, 4, 5, 6. So I want only 5 zeros. So this is your answer. Here I have 7, 5, 4, put some zeros before the number, and from here I am going 4 places, 1, 2, 3, 4. So I have 0.000754. So that is my answer. Here again I have put a few zeros, and from here I am going to move 5 places, 1, 2, 3, 4, 5. So I have 0.00003. Correct? So that is how you get the usual form from the standard form. Now let's look at the exercise. Express the following numbers in standard form. So this can be done here itself. 8.5 into, okay, how many places have I moved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 10 power minus 12. Okay, and over here it's going to be 9.42 into, again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again it is 10 power minus 12. And over here it is going to be 6.02 into, now from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 10 power 15, right? And here it's going to be 8.37 into, so from here 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 power minus 9. Okay. And here it is 3.186 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 power 10. So that is your first question. Now express in usual form. We'll do it on the whiteboard. 3.02 into 10 power minus 6. Minus 6, right? So put a few zeros to the left. I'm starting from here. 1, 2, 3, 4, 5, 6. So the answer is 0.50 and 302. Okay, that is the first question. The second bit, 4.5 into 10 power 4. So write a few zeros. So from here 1, 2, 3, 4. So here I am going to place the decimal. It's going to be 45,000. Next I have third question, third bit. 3 into 10 to the power of minus 8. 10 to the power of minus 8. So put a few zeros and then start from here. 1, 2, 3, 4, 5, 6, 7, 8. So here's where my decimal is going to be. So I have 7 zeros, right? Yeah. 1, 2, 3, 4, 5, 6, 7. Okay. And then the fourth bit, the question is 1.0001 into 10 to the power of 9. Okay, so place a few zeros after this and start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is, I have after the 1, I have 5 zeros. Okay, that is my answer. Next question, 5.8 into 10 to the power of 12. You're going to get a lot of zeros now. Write a few zeros. Okay, from here I have to go 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm going to write 5, 8, and I have 11 zeros. 11 zeros. Okay, if you count carefully, you're going to have 11 zeros. Right. Next question. Next bit. 3.61492 into 10 to the power of 6. Okay. Let us see. From here, 6 places. 1, 2, 3, 4, 5, 6. So it is 3614920. That is your answer. Next question. Express the number appearing in the following statements in the standard form. So here, this is nothing but you have 10 power, you have 6 zeros, 10 power 6 in the denominator. So this is nothing but minus 6. That is your standard form, right? Now here I have to write it as 1.6 into something. So let me see how many decimal places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it is 10 to the power of minus 19 coulombs. Right? Next one I have 5 into, so from here 1, 2, 3, 4, 5, 6, 7. 10 to the power of minus 7 meters. And the next one, size of a plant, 1.275 into 1, 2, 3, 4, 5. 10 to the power of minus 5 meters. Right? So thickness of the paper is 0.07 mm, which is 7 into 10 power minus 2. You can see it's 1, 2, right? Mm. So that is your third question. In the fifth question, they're saying in a stack, there are 5 books each of thickness 20 mm and 5 paper sheets each of thickness 0.016 mm. Find the total thickness. So here you can see that you need to add two numbers, right? Two different numbers over here. And before that, let us look at it. 5 books each of thickness 20. So 20 into 5 is 100, right? 100 mm. And this is the thickness of the books. And then there are 5 paper sheets, each of thickness 0.016 mm. So now for this, 5 into 0.016, 5 paper sheets together is going to be 0.080, which is 0.08 mm, right? Total thickness both are in mm, so I can add them. 100 plus 0.08 is nothing but 100.08 mm. Now I want this in the standard form. So this is nothing but 1.0008, right, into, I have moved it 2 places. So 10 square mm. So that is your final answer of the total thickness of the stack. So with this, we finish the 10th chapter, which is exponents and powers, where we have looked at the laws of exponents, the 6 laws of exponents. First, we saw the term, what we mean by a power m, and then we looked at what is a base, what is the exponent, and how we call it as a to the power, raised to the power m. And then we looked at the laws of exponents, the proofs of it, and solved a few sums. And then in the second exercise, we looked at the standard form of exponential form. So in the next video, we will start the 11th chapter.